these are the lesson activities for lesson 1.1 part 1. We're going to skip over the introducing yourself part because this class is being run remotely. Hopefully you did introduce yourself in the discussion forum for introductions. So we'll just jump right here to number 1. Consider the differential equation dy dt equals y squared minus 1 over t squared plus 2t. Which of the 3 functions below represents a solution to the differential equation? Okay, so we're just going to start with y1. So y1 is 1 plus t, and that means that dy dt would be 1. So we're going to plug that into the given differential equation. Dy dt, does it equal y squared minus 1 over t squared plus 2t? So dy dt is 1. So I figured that out over here, so I'm replacing that. And then y squared, that would be 1 plus t squared minus 1 over t squared plus 2t. Question mark, are those equal? So 1, does that equal, I'm just going to simplify the right-hand side right now. So I have 1 plus 2t plus t squared minus 1 over t squared plus 2t. My 1 minus 1 cancels. Does 1 equal t squared plus 2t over t squared plus 2t? It does, because when you have something over itself, that is 1. So I have 1 equals 1, check. So that means y1 is a solution. Okay, let's look at y2. Do another color so we can keep track here. So y2 of t is 1 plus 2t, which means y2 prime, the derivative, would be 2. So then plug into the differential equation. Dy dt, does it equal y squared minus 1 over t squared plus 2t when you plug in y and y prime? So dy dt, that's 2. Does that equal y squared minus 1? So that would be y is 1 plus 2t squared minus 1 over t squared plus 2t. Okay, so I'm going to simplify the right-hand side, and I get 1 plus 4t plus 4t squared minus 1 over t squared plus 2t. Those 1's go away, and I can factor out a 2 from my numerator. So I get 2. Does that equal... Should I factor out a 2? Or I'll factor out a 4. 4 times t squared plus t all over t squared plus 2t, and nothing cancels. Yeah, nothing cancels, so I can't make this equal 2. So y2, not a solution. Okay, let's go ahead and look at y3. So I'm running out of room here, so I'm just going to do it over in this margin. Luckily, y3 is just a constant. y3 equals 1. So dy dt, does that equal y squared minus 1 over t squared plus 2t? Now, if y equals 1, then dy dt is 0. Does that equal 1 squared minus 1 over t squared minus 2t? Well, 1 squared is 1, minus 1 is 0, so does 0 equal 0 over t squared minus 2t? It does. 0 over anything is 0. 0 equals 0, check. So y3 is a solution. Okay, similar question. Consider the differential equation y double prime equals y. So this is a second order differential equation because it has a second derivative in it. And which of these three functions represents a solution? So let's start with y1, which is c e to the t. So I'm going to need y double prime to plug in here. So y prime is c e to the t, and y double prime is also c e to the t. So if I plug into, I want to check, does y double prime equal y? So replace y double prime with this, c e to the t. Replace y with this, c e to the t. Yeah, those are equal. Good. So y1 is a solution. All right, y2. y2 is c e to the negative t. So I'm going to check y prime, calculate y prime and y double prime. So I get negative c e to the negative t because chain rule. And then y double prime would be c e to the negative t. So then I check, does y double prime equal y? Well, y double prime is c e to the negative t. Y is c e to the negative t. So yeah, they're equal. So y2 is also a solution. All right, one more. Let's look at y3. C e to the 2t. So I'm going to have to calculate y prime and y double prime. So I have 2c e to the 2t and 4c e to the 2t. Chain rule. And then plug in, does y double prime equal y? Y double prime is 4c e to the 2t. Y is c e to the 2t. Those are not equal, so that's not a solution. Okay, is y equals 4e to the 3t times sine t a solution to the differential equation dy dt equals 3y plus 4e to the 3t cosine t? All right, so this one is much more involved than the previous two. I have a candidate solution, y, so that's this right here. When I'm plugging into the differential equation, I'm going to replace this y with this function, but I also have to replace dy dt. So I'm going to have to calculate dy dt using the product rule, right? So this is a function times another function. So to take the derivative, we use the product rule. So first times the derivative of the second plus the second times the derivative of the first, which would be 12e to the 3t. Okay, so I've got dy dt. I'm going to plug that in right here. Okay, so dy dt is this whole mess. Four e to the 3t cosine t plus 12e to the 3t sine t. Does that equal 3 times y, and y is 4e to the 3t sine t, copied from the given y, plus 4e to the 3t cosine t. So are those equal? So just simplify it quickly. 4e to the 3t cosine t plus 12e to the 3t sine t. And then simplifying on the right, we get 12e to the 3t sine t plus 4e to the 3t cosine t. Yes, those two sides of the equation are equal. So yes, it's a solution. Okay, so I normally don't do videos for the even more practice, but I am going to continue because I think it's important to get this review done. It's just some algebra and calculus review. Okay, so I want to solve this equation, simple algebraic equation. So I'm going to isolate the exponential, so subtract 12 from both sides, and you get 5e to the 7t equals 3. Divide both sides by 5, e to the 7t equals 3/5 or 0.6. And then you take the log of both sides. Whenever your variable is in the exponent, you take the ln of both sides. So the ln of e to the 7t equals the ln of 0.6. And then you can bring your exponent down in front of the log. So we get 7t ln e equals the ln of 0.6. And the ln of e is 1. So that just sort of goes away. 7t times 1 is 7t equals the ln of 0.6, and then divide both sides by 7. So that's an exact value for the solution. If you want an approximate value, you put that in your calculator. Okay, to solve a logarithmic equation, you want to isolate the log. So I'm going to start by multiplying both sides by 2. So I get the ln of 7x plus 1 equals 2. And then you change it to exponential form. So there's a little hidden base e there. Ln means log base e. And so e is the base, 2 is the exponent. So this says e squared equals 7x plus 1. E squared is just a number, so now we just finished solving for x. So 7x equals e squared minus 1, and then divide both sides by 7. E squared minus 1 over 7. Okay, now we're going to use calculus to determine where a function is increasing, decreasing, and flat, flat meaning horizontal tangent line. Okay, so increasing happens when a derivative is positive, so y prime positive. A function is decreasing when its derivative is negative, and flat when its derivative is 0. So that means I have to take the derivative, right? So y prime is going to be 3t squared over 3, which is t squared, plus 4t minus 4. And now I need to analyze where this function is 0, bigger than 0, and less than 0. So first let's find out where it's 0 by setting it equal to 0 and solving. So this doesn't factor, so we're going to have to use the quadratic formula to find the zeros. So we get t equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So t is negative 4 plus or minus the square root of 32 all over 2. And just to give us an idea of an approximation, we would get t is approximately, negative 4 plus root 32 divided by 2 is like 0.83. And negative 4 minus root 32 over 2 is negative 4.83. So I wanted those approximations because I'm going to put these on a number line. So I needed to be able to see approximately where to put them. So let's see, zeros here, and then I have negative 4.83 and like 0.83. Those are my fences, places where the derivative is 0. And I'm looking at y prime. I want to look at the sign of y prime. It's 0 at these places. Y prime is 0 at those two values. We just figured that out. Now I need to figure out the sign of y prime in between all the fences. So you can pick any number to the left of negative 4.83 and we'll plug it into y prime, right? Remember, y prime is this. Okay, so I'm going to plug in like negative 10. if I plug negative 10 into t squared plus 4t minus 4, I'm going to get 100 minus 40 minus 4, so that is positive. And then I'm going to plug in something between negative 4.83 and 0.83, like 0. If I put a 0 in for t, I get negative 4, so I get a negative. And then put in something bigger than 0.83, like 10, and I get 100 plus 40 minus 4. That is going to be a positive number. So now that I've looked at the sign of y prime, I can use that to analyze y. When y prime is positive, y is increasing. When y prime is negative, decreasing, increasing. So y is increasing on the interval negative infinity to negative 4.83, unioned with 0.83 to infinity, and then it's decreasing on negative 4.83 to 0.83. Okay, now for a little calculus computation review, derivatives and integrals. So h of x is square root x times tan x, which means to take the derivative, we'll use the product rule. So h prime is going to be first times the derivative of the second plus the second times the derivative of the first, which would be 1/2 x to the negative 1/2. Okay, b, I'm going to need to use the quotient rule. So k prime would be denominator times the derivative of the numerator minus the numerator. Oh, I don't have enough room. Move this over. Okay, denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, C, y equals e to the negative x plus 4. So this is a chain rule problem. That's e to some stuff. So the derivative is e to the stuff times the derivative of the stuff, which is negative 1. So this is going to be negative e to the negative x plus 4. And then b of x is the ln of 5x plus 7. And the derivative of the ln of some stuff is 1 over the stuff times the derivative of the stuff. So b prime is going to be 1 over 5x plus 7 times the derivative of 5x plus 7, which is 5. So that ends up being 5 over 5x plus 7. Okay, and some integrals, and I've given you a hint on each of these on what technique to use. So this first one says u sub. So the inside of a composite function is always a good option for u sub, especially if the derivative of that thing also shows up in the integrand. So the derivative of x cubed is x squared, ignoring the coefficient. So this is a good choice for u. So u is going to be x cubed minus pi. Du dx is 3x squared, and then solve for dx. So dx is going to be du over 3x squared. And then we plug that in to my integral. So this is going to be the integral of x squared times the sine of u times dx, which is du over 3x squared. So the x squareds cancel, and this becomes 1/3 the integral of sine u du. And a function whose derivative is sine would be negative cosine. So this is negative 1/3 cosine u plus c, and then replace the u. So this is negative 1/3 cosine of x cubed minus pi plus c. Okay, for part B, we're supposed to use partial fractions. So that means factor the denominator. So I'm going to set this up without writing the integral first. I'm just doing the partial fractions thing. So this is going to become 6 over, let's see, if you can factor this, it would have to be a 2x and an x. And then the minus 1 means I have to have, these have to be both 1s. So now I just have to figure out, do I put positives or negatives? So I have plus 2x minus x. That'll work. Yep. And then I want to break this down into the sum of two fractions, a over 2x minus 1 plus b over x plus 1. And to figure out what a and b are, you multiply both sides of the equation by the common denominator, the 2x minus 1 times x plus 1. On the left, you just get 6 because everything cancels. On the right, you're going to have a times x plus 1 plus b times 2x minus 1. And the trick here is that this equation has to be true for all x's, so pick a value of x that is helpful. So if x is negative 1, then my equation says 6 equals 0a, and then equals negative 3b. So now we know that b is negative 2. And then if x is a half, then I get 6 equals 1.5a plus 0b. So 1.5 goes into 6. 4 times. So a is 4. Okay, so I have run out of room, but I think I have enough to finish up here. So that means I'm now going to, instead of taking the integral of this, I'm going to take the integral of this, but replacing the a and the b. So I have the integral of 4 over 2x minus 1 dx plus the integral of negative 2 over x plus 1 dx, and then each of these is an ln. That's 1 over some stuff, so it's the ln. Okay, so this one is going to be 4 times the ln of 2x minus 1. But then quickly go backwards. The derivative of ln of 2x minus 1 is 1 over 2x minus 1 times 2. So I don't want an 8 in the numerator. I want a 4. So I'm going to change this to be a 2. So that when you take the derivative of that, you get 2 times 1 over 2x minus 1 times 2, giving you the 4. All right, and then my next one is minus 2 ln x plus 1 plus c. Okay, part C, x cosine x, and it says by parts. So I have to choose a u and a dv. So I want to choose my dv to be something I can integrate because I'm going to have to calculate v, but also as complicated as possible. So my choices for dv are x or cosine x. And I'm going to choose cosine x because it's more complex than x, but it's still very easy to take the antiderivative. It's sine x. And that leaves x to be my u, which means du is 1 dx. And then my formula is the integral of u dv is u times v minus the integral of v du. Okay, so u times v, that's x sine x, minus the integral of v, which is sine x, times du, which is just dx. So this is x sine x minus the antiderivative of sine. A function whose derivative is sine would be negative cosine, so it's negative cosine x plus c. All right, and then the integral from 1 to infinity of 1 over x squared dx. So this is an improper integral. So the way we do this is instead of going from 1 to infinity, which is like, what does that even mean? You go from 1 to b, and I'll rewrite this as x to the negative 2 dx, and take the limit as b goes to infinity. So limit as b goes to infinity of, okay, so the antiderivative of x to the negative 2 would be add 1 to the exponent, x to the negative 1, divide by the new exponent, which just makes it negative, and evaluate that from 1 to b. Okay, so first we plug a b in for x, and so we get negative b to the negative 1, which would be like negative 1 over b, minus, then plug a 1 in for x, and you get negative 1. So now when you take the limit, this goes to 0, because as b gets really big, in the denominator, the fraction gets really small, so this is just 1.